All right, in the last video, we used our proposition about what it means for matrices to be similar. We used it to prove that pairs of matrices are not similar. So the first two didn't have the same determinant. The next two didn't have the same characteristic polynomial. I want to do one more example. I want to consider these matrices, 1, 1 on the diagonal, the identity, and then 1, 1, 0, 1. I want to show that they have the same characteristic polynomial. Right, so 1 minus x, 0, 0, 1 minus x. This is 1 minus x squared. This is 1 minus x squared as well. These are the same. Show that E1 of A, so the only eigenvalue is lambda equals 1. I want to look at its eigenspace, so E1 of A and E1 of B. I want to show that they're different, that they don't have the same dimension. So let's look at E1 of A. That would start with 1 minus 1, 0, 0, 1 minus 1. It's actually just 0. So if I reduce, I still have 0. I have two free variables. And so I get xy is st. So I have 1, 0, s plus 0, 1, t. My basis is 1, 0, 0, 1. And so the dimension is 2. I want to do the same thing for E1 of B. In that case, I'll get 0, 1, 0, 0, and so S only have one free variable, so already you see X is free. Sorry, what did I do? No, this one is free. I'm so used to putting the second one free. So X is S and Y, the second equation, Y is 0. And so I get a basis for E. So basis for E1B is 1, 0, and so the dimension of E1B is 1. And so they don't have the same dimension. All right, I want to show that A and B are not similar, but if you look at this proposition here, part 6, the dimensions need to be equal if they're similar. And so in this case, we just show the dimensions are different. It was 3.2, part 6. If the dimension of E1 of A and the dimension of E1 of B are different, that means A and B are not similar. All right, so we're getting closer to the truth here. We're getting closer to a full description of when matrices are similar. It seems like they need the same characteristic polynomial and also that the eigenspaces for the same eigenvalue have the same dimension, so they're isomorphic. Right, so that's what we know so far. We want to see when that's enough and if that's enough in the following sections.